All right, class, here we are in chapter 4, section 2, it's the structure of the nuclear atom. Let's start with this. So the atom itself is the smallest unit of an element of matter that retains all the properties of that element. And we follow Dalton's model of the atom, which is a simple solid sphere. It's obviously been revised since then. Once Dalton established the existence of the atom, new questions were asked, like what is an atom like? Is the composition of the atom uniform throughout? Is the atom made up of smaller particles? And research began to find a connection between matter and energy. There was a question of how electricity would behave in the absence of matter as well. So then we look at the cathode ray tube invented by Sir William Crookes. You can see the cathode ray tube shown here in another picture. He observed that when an electrical current was applied, a beam of light was produced originating at the cathode and moving towards the anode. The cathode is the negative end, and it would move towards the anode, the positive end. So you can see here a slit, the visible cathode ray, and the phosphorescent background strip. You can see the visible cathode ray moving from the cathode towards the anode. And that happens when an electrical current was applied, a beam of light would be produced. He called this ray a cathode ray, and he hypothesized that the ray was composed of negatively charged particles because they move from the negative end to the positive end. So they're basically being attracted to the positive end. J.J. Thomas was an English physicist, and he performed several other experiments using the cathode ray tube. He put a paddle wheel inside the cathode ray tube, as shown there, and he observed that the paddle wheel actually spun. So he concluded that something with mass was actually moving the paddle wheel. When you look at these years, 1856 to 1940, that was a long time ago. 100 years ago, they were already able to figure some of this out, which is interesting. J.J. Thomas, the English physicist, performing several other experiments using the cathode ray tube, then put an object in the path of that cathode ray, and he observed that the cathode ray actually cast a shadow. So then he concluded that it must have mass, and also the ray had to consist of particles moving in a straight line because they were able to cast a shadow. So let's see what this brings us to. So we have J.J. Thomas then using a magnet to determine the charge of those particles. In the first test, he placed the negative end of the magnet near the cathode, and the ray deflected away from that magnet. And in the second test, he placed the positive end of the magnet near the cathode, and the ray was actually attracted to the magnet. So he concluded that the cathode ray is actually composed of very small, negatively charged particles, because when put in the experiment, they would be attracted to the magnet, so the negatively charged particles would be attracted to the positive magnet. And this is where we get the idea of an electron, a small, negatively charged particle. So J.J. Thomas then performed an experiment using the magnet to determine the charge of those particles, which he found out was negative. So in his experimentation, Thomson actually determined that the mass of the electron was much less than the mass of the atom. The mass of the electron is considered to be negligible because it's so small that it's considered to be almost nothing. Although his work was hard to accept because of new revolutionary ideas, he was correct, and he was awarded the Nobel Prize in 1906, J.J. Thomson. Robert Millikan then was a little bit kind of in the same years as J.J. Thomson, maybe a little bit younger. He performed the oil drop experiment, which was done in the early 1910s, and confirmed that the charge of the electron was negative, and also was able to determine its mass. And please watch this YouTube video to watch that experiment a little bit more. I've linked these PowerPoints so you'd be able to get to that. He used the known charge to mass ratio and found the mass of the electron to actually be 9.1 out of 1,840th mass of the hydrogen atom. So it's incredibly small. So here's the actual link to this YouTube video. Please watch these YouTube video links on your own. And again, I've linked these PowerPoints in Moodle. So I'll let you watch those YouTube links on your own about this oil drop experiment and how Robert Millikan was able to determine the mass of an electron. So J.J. Thomson's model is known as the plum pudding model, where there's a spherical cloud of positive charge with negatively charged electrons in that cloud. With every new discovery, new questions arose, and the search was on to answer the new questions and make new discovery. The big new questions after this second model of the atom by J.J. Thomas was that if there are negative particles and the charge of an atom is neutral, well then what is the positive particle and what should we call it? Also, if the mass of an electron and those are questions that were then further answered. Ernest Rutherford worked with a group of scientists to see how alpha particles, the positive particles, interacted with solid matter. The alpha particles they found were positively charged particles that are released from the atom. Ernest Rutherford did the gold foil experiment, where atoms are composed of mostly empty space, and the positive particles went through the foil but approached a small dense area of positive charge, which was deflected at an angle. These positive particles hit dead on a very small dense area of positive charge and then shot backward. And again, there's a YouTube video link that explains this gold foil experiment, and I would encourage you to watch that as well. So he then, this last point was then he discovered the nucleus and found that positively charged particles called protons were one subatomic particle of that nucleus. So by 1920, Rutherford and the company refined the concept of the nucleus and concluded that the nucleus contained positively charged particles called protons that accounted for slightly less than half of the mass of the atom. So a proton was about 1.67 times 10 to the negative 23 grams. But what makes up the other half of the nucleus then, or the atom? Even after all this discovery, there was still another question. What makes up the other half of the mass of the atom? We know that there's a proton making up about half, and then we know there are the protons positive. We knew at this point there were electrons that were negatively charged, but they have practically no mass. So what makes up the other half of the mass of an atom? And then what contributes to the chemical properties of the atom? So this brings us to James Chadwick, 1932. He was a co-worker and discovered he bombarded beryllium with alpha particles, and that released what we now know as neutrons. So Chadwick was the man to kind of discover this third subatomic particle called a neutron. Neutrons have a neutral charge, and they have a slightly larger mass than a proton at 1.675 times 10 to the 24. 10 to the 24. So then we get to this third model of the atom, which includes the Rutherford model as shown here. We have the central nucleus made up of protons and neutrons. Protons are positively charged, neutrons have no charge, they're neutral, and then they are surrounded by an electron orbit of electrons. And that is where we'll end this section. And finally, in section 3, we'll compare a lot of these atoms together. Thank you for listening, everybody.